used by some musician or music company for playing their music in my videos. I have never ever played music in any of my videos. I said, why am I getting this? I had to contest it and whatnot. Anyway, here we are. And let's continue on with whatever we're doing. There's the link, we just looked at that. And pointers, we want to talk about pointers a bit. Also, did we talk about character sequences last time? It's not that, maybe I'll talk about that briefly here, character sequences. I was getting people ready for the exam. So you want to think about getting ready for the exam. So strings, character sequence, is basically, the word string. The string is a sequence of characters, and there's a data type called string. And there it is right there. Here's the data type being used here to declare S of type string. And they are sequences of characters. You'll see here S is A, B, C. And we didn't talk about this at all? We didn't talk? Okay. And you'll see there's two ways of dealing with strings. There's the old-fashioned way, and which is based in C. So the C++ language has come out of an earlier language called C. Let's make that a little bigger. So a lot of times you see ways of doing things that look like the C language. So I'll start by looking at that. So in the C language, you represent a string or sequence of characters with an array. So we could have like char, say, A equals, we'll use the notation we learned last time. It's an array of characters. So it'll be A, say we'll have A. And just to show you it doesn't need to be in order, there's a D. And 9, that's a character. See, if I do it like this, 9 is a number, right? Not a character. G, what is that, 4? So I can do, say, I thought we looked at this last time. So here's the character 5. And here's the value 55. So we're putting that into an array of chars. So this 55 is converted into a 1 byte, it's represented using 1 byte. Let's see if that holds up there. And we need a semicolon. What happens if we print that out? There it is, A57, what is that, 57? A57G question mark. What is that? A57, is this the value for 7? And you know why it's coming out like that? Because I need a 0. I need a 0 at the end here. Because, oh, this is funny. This is, so when we outputted this A, we got the printout A57G. Now, by convention, strings are terminated with zeros. Usually in code, you don't see the zero like that. Normally, you say, well, oh, this is a char. It's a character. Usually, we do this, like that. That's a zero. That's the same as a zero. So we use this slash, this backslash, for different things, like a new line, for instance. We could put a new line character in here. That's n, backslash n. So this equates to the numeric value 10. That's what that character is. This is 10 right there. And this is just a code for 10. It's backslash n. Why do they use that code to represent 10? Because 10 means in the typical context, it's taken to mean a new line. So n for new line. You see what happened? It prints an A, then a 5, A, then a 5, and then a new line. Now the console is a context that interprets a new line as an instruction to go to the next line and start from column 0 or column 1, however you want to label it. And then 7G. Do you see what's going on? What's going on with that 55? Huh? Am I recording? Forgot. Yeah, I'm recording. What is 55 here? 7. Yeah, 55 is the numeric value that represents the character 7. What the console got here, the console did not get numeric data 7 and say, oh, I have, a numeric value that is 7. It didn't get a 7, it got a 55. And with a 55, it said, oh, the glyph, I need to render a glyph. A glyph is what a character looks like visually. So what I have highlighted right there, which we call 7, is like it's a visualization of something. It's the computer's understanding of what 55 means. I need to render 55 to the user as this glyph, as this image. And that's how you have to think about it. 55 is the representation of a 7. Originally I didn't put a 0 here, so that gave us some trouble. Now this string doesn't have 0 termination. It doesn't have a 0 at the end of it. So when this output operation runs, it's going to send data to the console until it hits a 0 or an end of stream. And that's why we get something a little unexpected, because we don't know what comes after the G in memory. But it is a 0. How about if we did this? Let's put a K there, followed by a 0. Now we're not printing B. We're just defining it here. So that's 1, 2, 3, 4, 5. 6, 7, 8. So we got 8 characters here, Then we have 2 characters there. And we're just outputting to A. And I don't know, I've never done this before. I just think we're going to get something that I could talk about here. Oh, it does end with an S. So it doesn't go to the next line. Let me get rid of that one. We're still not getting, but we got a better result last time when I did this. Did we get something bad here? Huh?
What if you take out the new line?
Oh, yeah. Maybe that was it. That was it. Thank you. Yeah, let's see if that works. Well, we got it this time. But the boundary is funny because this we didn't print the K, but there's something in between. This thing gets laid out in memory, right? So A and B are laid out in memory somehow. And so when this output operation runs, it's scanning through memory. It finds, whatever numeric value represents it stands for A. It sends that to the console. Whatever numeric value that represents the character 5 gets sent to the console. We know what this is. It's 55. We'll send 55 to the console. Send the G to the console. And then it runs, it keeps going because it didn't find a 0 yet. So then it reads the next character, sends it to the console. And that character, the console says, well, you sent me something funny. You sent me a number, and that's the glyph for it right there. That's the glyph for the number you sent me. And then maybe there's either we hit the end of the program and what did we do? We hit some sort of memory boundary, or else we hit a 0 and then we're done. Another way to define these things let's look at this. So A is it's a pointer to data ABC. So this is how you'll see it in C language. Usually they don't put a space in there, or they leave they either do it like that or like that. So I do it like this. But this is not very common. And let's just take that out. So what happens here is that the compiler says, I'm going to put an ABC in memory, followed by a 0. So the numeric value for A, the numeric value for B, the numeric value for C, and then a real 0. That's 4 bytes. Char is 1 byte. So it lays out 4 bytes of memory, initializes 4 bytes of memory. And then when the program runs, this variable A will contain the address, the memory address of that sequence ABC0. That's what this asterisk means. It says that A is a pointer into memory. So A points into memory. And in that memory is the first byte in memory is a numeric representation of A. We don't have to put the 0 in there because the compiler will insert that for us automatically. So the size of the memory that's affected here is 4 bytes because of the added 0. Deprecated conversion from string constant to char pointer. Oh, that should be const. We got to declare it const. Here's the ABC. Const means that A can't be used in the program to modify memory. So if you wanted to insert the, if you wanted to change the A to something else, like a 5, let's say, the compiler's not going to let us do that. Assignment of read-only location star A. By the way, star A, we're not assigning 5 to A. We're trying to write 5 into the memory that A points to. So memory in the computer is sequential. There's byte 0, there's byte followed by byte 1, followed by byte 2, and so on, all the way up to 8 gigabytes or whatever the memory is these days. So A represents a byte number, like byte 1,000,009. And what we want to do is set byte 1,000,009 to the value 5. So you use this syntax. It's called dereferencing a pointer. That's what we say, dereference, because pointer is a reference. We want to dereference it to get that location it points to. So this is rejected because A is declared as a const char pointer. That's just that we're telling the compiler, we will not use A to change memory. We will not use A in an expression to modify the memory pointed to by A. We promise not to do that. But we're breaking a promise here, see? So the compiler calls us on that broken promise. It says, reports an error. Assignment of read-only location star A. So we're going to do something that's deprecated. So we're going to get a deprecation error, warning message here. It's not an error. See, it says warning. It still compiled the program, but it gave us a warning. So that's not safe. It's like a security issue here, something like a security problem there. And but if we run it, what's it going to print? 5 BC. Segmentation fault. Won't even print that. So I don't know what's going on there. So A is set to. Why don't let us do that, huh? We can't write into that part of memory. So I got that wrong. It let us run it, but it when we wrote into that part of memory, it failed on us here. How about if we do this? Let's do this. Let's declare A as an array of size 4. A is an array of char size 4. And we're going to initialize it to A, B, C, and then 0. That's the way it's usually done, like that. And then we could do this. Now it'll come up 5 BC. I think that's going to work now. Let's see. Let's see if I got it this time. Got it. Okay. See, the other one, the way I defined it the other way, it took the string data and it put it into a block of memory that the operating system doesn't let the program write into. It can read from it, but it can't write into it. That's why we got a segmentation fault. But now, the way I defined the array A, there's four slots in it, 4 bytes. It's in what's called stack memory. So it's a different kind of memory, and we'll read about that a little later. And we can we can write into the stack. We can modify bytes that are in the stack. So that's what we're doing there. There's another way. We could do it differently. Like what I showed you right there, using a pointer notation. We can also do it like this. This is using array notation. So at position 0 in the array A, let's put the character, the number that represents the character 6. Now we have 6 BC. And we can modify the other. Remember, this is different than, well, let me get rid of that. It's different than putting a 6 in there, right? Putting a 6 in there means the console is going to say, whoa, what's the glyph? How do I render 6 to the user? Is there a glyph for 6, or maybe it's a behavior like making noise? There's a character that represents the bell sound. Maybe it's a 6, I don't know. Let's see what happens here. Because we won't hear a bell, we're running remotely. So 6 is some kind of white space. We call it a white space. Does anybody know the tab character? Is tab a 9? I think tab is a 9. So let's put a 9. See, this here, this here is position 0. That's position 0. This is position 1, position 2, and position 3. The size of the array is 4. So when I go A of 1 equals 9, I'm overwriting B. So it'll print A something C. But I think there's some, what's the code for tab? Is it 9? Good. All right, so this will tab it over. So that means what this will do when this prints, it'll look something like this. It'll print A, I think 8 spaces. It's up to the program to decide how to render a tab. The old standard was 8 spaces. But you know, your editor might decide, well, I've got a tab character, I have to render it to the user, I'll use 4 spaces. And if you're in a programming environment, you can do what's called this tab setting. You can change the tab to whatever number of spaces you want. So it's just a way of how you want the application to interpret a tab character. There'll be A followed by a C. That's what it should look like. There it is. So 9 is a tab, thank you. There's another way for indicating tab, by the way. Usually we don't, almost never we use a 9 like that. Usually we use the sequence \t. Just like \0 is a 0, \n is a new line, \r is a character turn. That's 13. \t is a tab. There it is. And, you know, we could do the same thing using the pointer notation. So we're talking about pointers now, too. So basically, I use this, and I follow the asterisk here by a memory address. Is that 1D or 2Ds? It's 2Ds, isn't it? I know in French it's 1D or 2Ds. It's like different language. I get screwed up on that. All right, so we can do it like this as well. So if we pass in an address, and then we dereference the address, so we want to write a tab character at that byte. You're giving me a byte number, byte 0. By the way, it's illegal to write anything into byte 0. It exists in memory. It's the first memory location, byte 0. It's a very important byte because you're returning, it's called a null pointer. If your pointer is set to 0, it's called a null pointer. And that's a meaningful value. It's a very important value, most important address. But any other value, and it doesn't take negative, pointers can only be 0, non-negative. Of course, if you give it a value that's bigger than the available memory, that's an exception. That's a memory called segmentation fault, whatever. So we can pass in, if we use A, even though A was declared as an array here, the value A in code can be used. It represents the address of the first byte of the array data. So we can use A in code to represent the memory location of where the array starts. Wait, we did this already. Just to review. Oh, but see, we wrote over the A. See, we put the tab character in byte 0 of the array. But we want to put it in byte 1 of the array, right? But A is the numeric address of where the A is. So we want to go 1 past A. So this is called pointer arithmetic. If A represents the address of the first byte in the array, A plus 1 is the address of the second byte. So now we're going to write a tab character over the second byte, which is byte 1 of the array, because counting starts at 0. So that should give us what we had before. So that's how you do it. And we could have used, this is the alternative notation. Looks like this. What the heck? The alternative notation is this. That's the alternative notation to this. This expression is the same as star A plus 1. I'll prove it to you. Now these are experiments that you should do if you're a computer science or computer engineering major, or if you want to learn this stuff well. These are the kind of experiments you need to do. And really try to understand this stuff. So this is the topic character sequences. Oh, let me show you just a little more there. So this is all about, the old way of doing it, the way you would see it in the C language. Of course, they do it, that type of code reappears in C++ programs all the time. So, but now there's also something called a string. I'll call it A, just to be the same as before. So here we have a string ABC. And now we can print the string. This is a C++ feature. Did I get something wrong? Yeah. Oh, A, thank you. I could tell that body language there that I got something wrong. Thank you. Okay. So it's just more convenient to use this because you can get things like, well, A is now an object. We call it an object. It's a data type that's different. It's not a char. It's not an array of char. It's its own data type. And it's a data type that has something called the dot notation. We can invoke functions on instances of this data type. So size is one such function. There it is. And there's other functions like substring. If I take the substring, the value at 1, I'm going to take 2 characters starting at position 1. And by the way, I got to test this because I'm not sure if I got it right. I got it right. So that's substring function. The first argument is the starting position. The second argument is the number of characters. Actually, I'm not really sure about that. Let me see. If that's true, what I just said, then what does this print? If the second argument represents the number of characters, it'll just print B, right? That's not a good example. How about this? Starting in position 2, we print 1 character. What do we get? Just to be, so everyone can see, that's position 0, 1, 2, and 3, right? So we start in position 2, then we're gonna start at that C, and we're gonna print 1 character, so we just print a C. Let's see if that works. See, the other possibility is that the second argument is a position value, so we print between position 2 and position 1, which wouldn't make any sense in this case. So this is right. So this is the number of characters. So I had to do a little test there to remember. There's a language where, maybe it's Java, where the second argument is the end position. The first argument is the start position. So it kind of depends on the language. This substring function, there's that one little variation across languages. Yeah?
It's starting at position 2 and print 1?
1 character.
1 character, right?
Starting at position 2. If we want to print 2 characters starting at position 2, what's it going to print?
CD.
CD.
Oh.
And what about 2 characters starting at position 1? BC. What about 3 characters starting at position 0? Just ABC. All right, so you just practice this till you get it. And sometimes you want the old-fashioned C representation out of a string. So you use this C underscore string. We don't need it here, but sometimes when you need the old-fashioned C representation of a string, like a function takes a char pointer, then you pass it this. So if you had a function like this, so you had a print function. We don't want to print in main, we want to print down there. So we call print. We want to print A. But this won't work because A is of type string. The print function is of type const char pointer. Error, cannot convert string to const char pointer for argument 1 in the function. So what we do is we say, oh, we got to turn it to we want it to be given to the function as a C string. Now we're good. So a lot of APIs, take this, and then you got to use that to call into the API. Application Programming Interface, API. Yeah.
Sometimes on certain programs, in the main function,
Yeah.
I'll see that they write integer argc, comma, character star.
Yeah. You want
What is that?
so it's what do they have this, right? Char.
Star, AR, JS, and then the brackets.
Yeah, and that's AR argc, right?
Yeah.
Yeah, what's going on there? All right, get rid of this. This is the way to, this is an array. Args is an array of command line arguments. And so it's, see this, we talked about this already, a char pointer. It's just char pointer, it's not constant char pointer, is it? It's not const. Did they show a const char pointer?
No.
Just char pointer. So if they did it today, they would use const char pointer, right? But this is an old convention. So they're stuck with the old form. So this args, so remember this is so args is an array of char pointer. And each char pointer points to a string. I'll give you an example. Let's look at the first string in the array. By the way, argc is how many elements are in the args array. If argc is 0, so if argc is greater than 0, then we know we can access so if no arguments are provided, on the command line, then argc will be 0. Because this array, args, is an array. It gives us access to the arguments on the command line. Let me show you what I mean. So a dot out, there's this, here I put KKK on that command line. Anyway, I always end up using that example. PPP, that's better. So now I got one argument on the command line. So argc is 1, it's greater than 0. So we print, what the heck is going on? Why does it print ABCD?
Did you recompile it?
No, thank you. Oh my gosh. First argument of int main should be int. Oh, Warning, first argument of int main. Oh, first argument, not the second one, right?
I think they're supposed to be flipped.
The first argument should be an int. Second argument of int main should be a char pointer. Is that right? I don't do this enough. Is this what it says in the book?
Yeah.
This? Oh, so they have argc first. Oh. All right. Oh, I forgot. When the compiler processes this code, args always have something in there. Arg0 is always set. It doesn't matter what you put in there. Argz is always set to args of 0 is the command that you use to run the program. So it's a.out. All right. Now look at this, watch. Let's suppose I move a.out to run. Okay? I just changed the name of the executable from a.out to run. Now when I run, it prints ./run. Basically, arg0 is the file name that was used. It's the name of the executable that was given to the command line interface. But arg1 will not be defined because argc is going to be 1. It's of size 1. That's okay, see? But what happens if I do PPP? What's going to happen? Well, argc will now be 2. We need another string to represent, the first argument on the command line. So now we have an assertion failure. Argc equals 1 has failed because argc is now 2. And in fact, and I'll just take that out. So if there's 2 elements on the command line, the name of the executable followed by 1 argument, then we're going to have 2 entries in this args array. So let's print them both. See that? What happens if I do this? It means args1 is undefined, so we're going to get something unpredictable. We get nothing. Okay, well, that's not too bad. So it's a way to pass information into the command line. It's a way to pass information into the program through the command line. So suppose we have 3 arguments, or 2 arguments. This is not really an argument, that's just the name of the executable. Let's suppose we pass in 2 arguments. You can get them both. All right, that's it for that. Let's see what time it is. Using all our time on this. Any questions? Other questions on that? We're running out of time there. So we went back to get this. We looked at that. That was fun. And we started talking about pointers. And in fact, I think we may have covered enough about this. Null pointers. There's a special name for the null pointer. That's a 0, right? You could just put a 0 there, 0, instead of writing it out. But this is good documentation if you use the name. And by the way, this doesn't exist in older versions of C++. That name is, I don't know which version it's in. It's the same as this. Pointers to functions, that gets pretty complicated when you talk about pointers to functions, but you can do that as well. I think that's, and pointers to pointers is very important, pointers to pointers. So I think we'll wait. We don't actually, there won't be anything on pointers in the exam. But if you take Computer Science 202 next quarter, then you'll need to work with pointers. And in practice, pointers are essential and just everywhere and extremely important. Now, if you work in other languages, they may not use the word pointer, but there's pointers everywhere. Like if you work in a Java language, like most variable, unless it's a primitive representing a primitive data type, all variables are pointers in Java, except those that represent instances of primitive data types such as int and double. So the concept of pointer is essential. What else do we want to do here? 1 o'clock already. Coming back, let's look again at exam 1. We looked at some of this already. You know, these are exam questions. These are questions I gave on exams in the past. So this is, if you want to do well in the exams, you practice these. Does anybody have a question about any of these? Maybe you haven't started getting ready for the exam yet. That exam is coming up, right? May 2nd, yeah. And today is April 25. So it's next week. It's a week from today. So then this topic here, application development, and there's a bunch of other topics linked to the reading. But I like application development. I like that topic, so I thought I would focus on that a little bit in this class. And I started to play around with some code that maybe we could play with in this class to learn more about application development. So that link there comes to this source code repository, which, by the way, is, see this wiki link here? This is the course wiki. So this is just the wiki pages for the source code repository. At GitHub, this is a big resource that developers are using these days. You don't have to use GitHub. There's other versions. There's Bitbucket, and you can set up your own Git server and whatnot. But Git is a version control system that was originally developed to track and changes to the Linux operating system. It was specifically built for Linux, and it's just become wildly popular. So it's growing in popularity. So it's something that, as a developer, you need to understand. You need to know Git. And GitHub is a popular website that hosts Git as a resource for developers to use. You can get a free account. It's fantastic, actually. I recommend it. But I thought to show a little bit more about how to do application development. Now we would take a look at this Sdl library and just to play around with it. I'll show you how to build programs, talk about how you would write code in C++ that would use this Sdl library. And I got some notes here, and then I have some source code in there. And well, what is Sdl library? Oh, what the heck? Sdl library. That's what it is right there. Oh. Sorry about that. That link is bad. Let me show you. So this is the command line interface of Macintosh. What's the name of that? 201. So here's the README file that we're looking at. And I see this link here. This is called markup language. So I'm not on Cloud 9, but I have a command line interface that's a part of Mac OS 10. This is the link. This is the syntax for the link. I forgot to put this in there. I never tested the link. See. Now, see, there's the experiments folder. So this is my local copy of this remote repository. Here's the README file. This is where it's interpreted. So here's the raw version. See that? See, I'm missing that HTTP in there. So this is how you do it. This is software development. You know, if a software developer saw me doing this, they'd say, yeah, well, this is what they're doing too, or something like this. But a lot of them are doing exactly what I'm showing you. And so I made a change, right? So I got to make a change. I have to submit. So you've worked in these repositories. It's a collection of your source code. It's stored on a remote server. So normally you're working with other people. Right? We're working together. So we have to synchronize changes to source code. So we use this remote repository and we write our changes into it and we get the changes from other developers from it, merge them in with our own changes. It's a very important process, essential. So I have a local change here. So I use the git command. And it shows, oh, README has been modified. I'm going to add stage changes to README in what's called the index. And but it hasn't gone into the repository yet. So I have a local repository that I commit the changes into. I'm just going to put X, that's a comment. And it's showing me that my local changes to my local repository is ahead of changes that it has for the remote repository. So I need to push those changes to the remote repository. So that's the command I use for that. And there it is. See that link now should work, but I have to refresh the page. Now this link failed before, and now it works. That's it. That's a process, how to write into the repository. So what is SDL? This is the Simple Direct Media Layer. This is it's a library used for game development. And it lets you write code like in C++ or C. And then you can build it for different target platforms. So the code can build for Windows or Mac or Linux or Android and iOS. Those are the main targets, but they have other target platforms as well. It's actually used. I mean, this, I don't know if anybody knows this stuff. I don't know what these games are, but does anyone know these games? But there's games that use this. I played a game called, what is it? I bought it for my kids. What was it called? Shovel Knight. Anyone know Shovel Knight? Yeah. It's like an old pixelated side scroller that was rebuilt. And they use SDL for that, as an example. I think they use Sdl, but there's lots of games. The guy that worked on this is at Blizzard now. I forget his name, but he's had this library in existence for a long time now, and it's a famous library that's used a lot. So this is good for game development, and the documentation is in this wiki here. Let's see. This is the API, the Application Programming Interface. This documents the Application Programming Interface. So this is the API categorized into categories, organized into categories. There's the basics, video, input events, force feedback. You got things like, for instance, mouse support here, right? So the way to interact with the mouse on Mac is different than using a mouse on Windows. But if you use a library like Sdl, your code interacts with the Sdl API, and it just interacts with the mouse in one way. And so behind the API, the library is adjusting to the different platforms that it's built to run on. So it makes development go faster if you want to target multiple platforms. Audio, threading, timers, file abstraction, so on. It's been expanded in recent years. I mean, this was originally built before cell phones were popular, and but it now includes support for cell phones. Although I think it's hard to use for that purpose. And we're getting out of time here, so next time we'll see. Next time is Wednesday before the exam, and if you have questions about any of those sample problems, bring those questions in, and I'll cover that for you. And if there are no questions, or we answer all of your questions, then I'll maybe come back to this topic of application development. We'll look more at this.